Welcome to the TOEFL Listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Professor Mitchell. Thank you for meeting me. I wanted to get your feedback on my research design for autonomous vehicle safety protocols.
Good afternoon, David. Of course. Tell me what aspect of safety protocols you are focusing on.
I am looking at testing standards and validation methods that regulators and manufacturers use before allowing self-driving cars on public roads. I want to compare scenario-based testing, simulation, and shadow mode field trials.
That sounds appropriate. Make sure you frame the work in relation to the Operational Design Domain, or ODD. Testing protocols should be tied to the vehicle as declared ODD. Have you defined that yet for your test cases?
I have a preliminary ODD that covers urban low-speed conditions in clear weather, but I am concerned that the ODD definition limits the safety argument. How do protocols address edge cases near or outside the ODD?
Good question. Robust safety protocols include explicit procedures for identifying and handling edge cases. That is where scenario-based testing and fault injection become critical. You design stress scenarios that push sensors and perception algorithms to their limits, and then record failure modes.
When you say fault injection, do you mean physically degrading sensors or simulating sensor noise in software in the loop?
Both. Hardware in the loop and software in the loop let you simulate sensor faults and network failures, like CAN bus interruptions. Closed-course testing lets you intentionally degrade a sensor or mask a lane marker to observe system response. Protocols should mandate both simulation and controlled physical tests.
That makes sense. I've been reading about standards. ISO 26262 came up frequently. Is that the main standard for autonomous vehicle safety protocols?
ISO 26262 is fundamental for functional safety of electrical and electronic systems. But for autonomous systems, we also need ISO 21448, known as SOTIF, for safety of the intended functionality. SOTIF addresses hazards that arise when the system works as designed, but the environment creates unsafe conditions.
So SOTIF complements ISO 26262 by focusing on perception and behavior in complex environments?
Exactly. And protocols that regulators expect will reference both standards. In addition, manufacturers produce a safety case that documents testing, assumptions, ODD boundaries, redundancy strategies, and verification metrics.
What verification metrics are most meaningful? I've seen disengagement rate quoted, but I read critiques that it is insufficient.
You are right to be skeptical. Disengagement rate is easy to report, but it does not capture near misses or the diversity of scenarios. A comprehensive protocol uses scenario coverage metrics, incident and near-miss rates per million miles within the ODD, mean time between failures, and probabilistic safety targets derived from risk tolerability studies.
Can you give an example of a scenario coverage metric?
Certainly. One approach is to define a taxonomy of driving scenarios, such as pedestrian crossings at angled approaches, sudden cut-ins by vehicles, and occluded intersections. For each scenario, you define parameter ranges like speeds, lighting, and road geometry. Coverage is measured by the percentage of parameter space tested in simulation and on-road.
That sounds data intensive. How do companies manage the volume of data from fleet testing?
They use edge filtering and safety telemetry. Most systems run in shadow mode when they are not allowed to control the vehicle. Shadow mode lets the system run in the background and log decisions without taking control of the car. Those logs are then prioritized with automated triage to find rare events that require human review.
I see. So shadow mode provides real-world decision-making data while keeping operations safe. How does that differ from closed-course testing?
Closed-course testing is active validation of actuation and control under controlled risk. You can verify emergency maneuvers, braking performance, and fail-safe transitions. Shadow mode is passive and focused on perception and decision validation at scale.
You mentioned redundancy earlier. Could you elaborate on how redundancy is specified in safety protocols?
Protocols usually require dissimilar redundancy for critical functions. For example, primary perception may use LiDAR and camera fusion, while a secondary channel relies on radar and a simpler rule-based perception stack. The idea is to avoid common mode failures by using different sensor modalities and independent processing paths.
Does that mean every vehicle must have LiDAR?
Not necessarily. The protocol should show that the chosen sensor suite achieves the safety target for the ODD. If a manufacturer uses cameras and radar only, the safety case must demonstrate acceptable performance and redundancy for relevant scenarios. The documentation must include sensitivity analyses.
What about human interaction protocols? For conditional autonomy where a human can take over, how are transitions tested?
Transition protocols must be verified through human factors testing. Safety protocols include metrics for driver readiness, takeover time distributions, and safe fallback strategies. You also validate whether alerts are perceivable under different conditions. Takeover scenarios are part of scenario-based testing and must be in the safety case.
Are there named case studies that illustrate strong safety protocols?
Yes. For example, Waymo publicly describes a layered safety approach with simulation, shadow mode, closed course testing, and a formal safety case. Conversely, incidents such as the 2018 pedestrian fatality led to protocol revisions industry-wide, especially around perception edge cases and validation rigor.
I want to include a comparative analysis in my thesis. Should I evaluate companies' approaches against ISO 26262 and SOTIF, and also against scenario coverage and telemetry practices?
Yes. Compare compliance to ISO 26262 and ISO 21448. Then assess practical validation methods like Mill-Hill-Sill, shadow mode, closed course, and fleet telemetry. Also, evaluate metrics such as scenario coverage, near-miss rates, and how they define and prove their ODD. That will give you both normative and empirical perspectives.
One more question. For my methodology section, should I propose a test protocol that includes simulation first, then hardware in the loop, then closed course, and finally scaled shadow mode before limited on-road actuation?
Yes, that staged approach aligns with best practices. Include clear acceptance criteria at each stage and a plan for continuous monitoring after deployment. Also include contingency protocols for software rollbacks and over-the-air updates that affect safety-critical functions.
Thank you. This helps me structure the chapters and define concrete metrics. I will draft the protocol flow and the set of scenarios for coverage analysis and bring it to you next week.
Good. Make sure your draft ties each test to a claim in the safety case and references appropriate standards. I look forward to reviewing it.
Listen again to part of the conversation. Then answer the question.
Shadow mode lets the system run in the background and log decisions without taking control of the car.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.